Okay, here we have section 2.2, question E40, and it's asking us the concept of the trimmed mean. So sometimes you'll get a couple outliers that are low or high that are really influencing the mean. Now the nice thing about a median is that those outliers would not influence it. Certainly not as much, but a single one or two outliers can really affect what the mean is and give kind of a distorted representation of what the center of a data set is. So when we look at trimmed mean, we're cutting off the largest 5% and smallest 5% of the values and then computing the mean just like we normally would with any remaining values. So notice it does mention software here, and we're going to get into that in just a second. So we have find the trim mean of the maximum longevities in the figure below. So we have a data set here. We're looking at some different mammals, how long their pregnancies are, how long they live on average, kind of their maximum. So if you have a really healthy or a good genetic version of one of these mammals, this is how long they might live. Their speed, whether it's a wild animal, and whether it's a predator or not. But they're not asking us all of those, they're just asking us about the maximum longevities. So if we're going to get a trimmed mean here, 90% middle, we need to pull out the 5% top and the bottom 5%. So we need to know really how many we're pulling out. So first of all, we need to know how many animals are in the chart, and they are grouped by 5, so we can count 5, 10, 15, 20, 25, 30, and this last one's a little bit off, but we do see that there's 39 here. So if we're looking for taking off 10% of that 39, that would be 3.9. Would be much easier, of course, just to remove 4. So we're going to take away the lowest 2 and the highest 2. Now notice that these longevities are not in order, so we are going to have to be careful where we choose the lowest 2 and the highest 2, the way that we identify them. The other thing you might notice is that's a lot of numbers, so we need to somehow calculate the average, take out the bottom 2, the top 2, and get the average. Now we could eyeball it, figure out the lowest 2, the highest 2, and then type all these into a calculator. I'm going to show you a different way that we can do this. So if we get out of this screen and go back to our general Wiley screen, one of the things that we can do is read, study, and practice. So I'm going to go there, and here we have the option of selecting a chapter. I'm going to select chapter 2, and notice that I'm given a list of resources. Well, one of those resources is the data sets. So I'm going to get the data sets from chapter 2. I'm click on that and it downloads to my, and I think I'm getting blocked here by the video screen. So if I open that file that downloads, it's a zip file, and I'm in section 2.2 right now. I want to click on that, and these give me all the data sets that are in the chapter. So if you don't want to worry about typing these out by hand, notice we're looking at the mammal sample. So I pull that open. In the mammal sample, if you have Excel, this is what you'll see. If you don't have Excel, they also have text files that you can open. If you do have some other kind of, such as OpenOffice, you can do that. I'm going to show you some real quick tricks here in Excel. If you select all the columns in your chart and just extend one, all of the columns will extend that same amount. And the reason I'm doing that is so I can actually read what these columns represent. And I've already sorted this, but when it came in, the maximum lifespan, this maximum longevity, was not in order already. So the way that you would do that is you drag across all the columns, and you would go up here to Sort and Filter, Custom Sort. Notice there's a check for my data has headers. It does pick that up fairly well, but you may need to double check to make sure it is identifying that first row as headers. And then it gives us all the different columns we can sort by. So we want to sort by maximum lifespan. And then we can do smallest to largest. That doesn't really matter. So I'm clicking OK. So what that does, it sorts everything by maximum lifespan while keeping them in order. So if I were just to sort on this column, everything else would stay in the original order, so these numbers would not match up with the correct row headings. So that's why I selected all the columns. Whenever I do a sort, I want to select all the columns in my data set. So here I see that mouse as the most unfortunate lifespan, followed by opossum. And I'm wondering if the possums there are factoring in the cars that they encounter along the way. I'm guessing if they didn't have cars, maybe that would be a bit higher. And elephant here we have up to 70, which is quite a bit higher than anything else. So notice that that elephant probably is pulling the mean up somewhat unnaturally. Now remember, the task is I want to take the average of the middle 36. So I don't want to count the mouse or the possum. I don't want to count the elephant or the hippopotamus. Now there's a real quick way to do this in Excel, so let me show you. If you select, notice I didn't select the top two. I select and drag down all the way down to the gorilla, so everything except those first two and last two. All that I've done is select those. But if I go, and I'm running into a problem here where you're on it. Here we go. I know you probably can't see this very well on your screen, but what happens when you just select cells in Excel? It gives you count, the number of cells you selected, sum, the total of the values in those cells, and average, the average of the values in those cells. So here I can see my average is 30.5. Again, I realize you probably can't read that, but when you do this in Excel, look down here for that average. I can't remember if OpenOffice has something similar, but right away I know that my average is 30.5. So I go back, unfortunately, and this is something I'm reporting to Wiley, we do have to click back through to get to that question we were doing. So we're going back to the question 2.2 E40. Now what you can do is you can download those data sets in advance. That way you don't have to actually leave the question to find that. So the trim mean was 30.5. And again, that was just because I highlighted all those cells except the first two and last two and found the average there. I could have, of course, typed all of these in and then divided by 36. In fact, I wouldn't have even had to go to Excel. I could just identify the lowest two, top two, take them out, type in the other 35, I guess it was, and divide by 35, and that would also give me 30.5 as the trimmed mean. Is the trim mean affected much by outliers? In this case, no. How do I know that? Well, let's get the total average. So instead of excluding those 4 data points, I'm going to select them all. And again, you can't see this very well, but the average now says 30.8. So if I do take the average of that entire data set, that would be 30.8, which is not much different than this 30.5. So the trim mean in this case really is not. It's pulled up a little bit by the elephant, but it's not really that affected by outliers.